What's up, DIYers? How's life going on these days? In this video, let me demonstrate once again the effective use of the OSC482 oscilloscope, the virtual oscilloscope from Loto, while I'm traveling somewhere on Earth. Guys, I'm not yet allowed to travel to Mars, and I still gonna able to do my DIY hobby in here, right here at the comfort of my apartment. Guys, before anything else, before I'm going to deep dive on the demonstration, I would like to mention that this demonstration has nothing to do with the DR 100 watt class D power amplifiers in terms of its sound performance, in terms of its high fidelity. Let me introduce to you these blinking LEDs in the A3CS board. This red board is a A3CS board. I call it that way. That's my own design. It's a blue LED, keep blinking like this. That is a TX LED, and then sometimes the RX LED will blink also like a you know that's how I interpreted the LED, like doing like this. And that's the one that we are going to investigate it using the OSC482. And as you can see in here, I already have those oscilloscope and prove it to the LEDs of the Arduino Uno, I should say. I'm very specific now to the Arduino Uno because I'm using that board as a unit under test for the demonstration. And I cut it short with all the setup I have done in the previous video, like the video part number 1 and the measurement in part number 2. And then I go straight on how to go for the measurement. Since I'm going to make use of 2 channels oscilloscope, so I definitely need to enable channel B. And my interest right now is a DC voltage, not an AC signal. So I'm going to choose also the DC in here for channel A and also a DC. Oh, DC already in the channel B. And before I'm going to start, I am going to put the time base into its maximum so I can see the signal initially. Start the device and you can see already that the blue, which is the TX LED or LED one, I can see the signal already in here, and I can adjust that into 100 milliseconds to have a deeper capture of the signal, like what you can see in here. This is the TX signal and this is the RX signal, which is responding correctly. And I can even go to a deeper with a 200 millisecond. It's loading, and I can put that into a full screen like what you can see in here right now. So what I can do next then is to especially set the trigger. I'm very specific to that signal only, and then like the TX LED will going to see the waveform, and then the RX will come in, and then I just wanted to stop it when the whole process will be finished. I'm not interested with the repeated cycles, just one. So I'm going to enable the channel A trigger. I'm going to put that into 10 milliseconds, and then I'm going to go to the trigger. And there you go. There are 2 kinds of triggering in here. One is the positive going up and the other one is a negative going down, and I'm going to explain later why I need to choose the trigger to be in the falling edge. But first of all, I'm going to enable the trigger, which is on the channel A, and you can see the capture already. It's perfectly triggered with the LED one in the blue and the yellow one in the LED 2 or the RX LED. Now, I would like to mention about the triggering, wherein why I selected the negative one in here, which is the reason why is that the signal in here is plus 5 volts, and then it go down in here. Okay, so I need to trigger when it goes down in here at a level of about 2.744 volts. So it will going to trigger in here, and then capture the whole signal and then stop. And that is the reason why we can only see one signal in here instead of the repeated signal. What I want is that I just very interested in one of the TX signal, wherein that is my point of interest. I would like to emphasize also in here about the normal and the single, which is mean I do the single. Actually, it means to say that there is only one waveform for me to capture in a single shot. So I'm going to use the single, as you can see in here. So I'm gonna work on here, and I'm going now to the storage mode. Stop it, and I can actually expand this one. You can see I expand the waveform, and I can use this mouse to just click, right click, and then drag it, something like that, and you can see the clear signal. Or you can use this slider in here. You can actually remove the grid in here by clicking this grid icon, and there you go. I'd like to resurface this schematic diagram. Oh, that's not the schematic diagram. Actually, watching my YouTube channel. This is it. Yeah. I have all the opportunity to watch all the YouTube channel right now, and because I'm not inside China right now, you can probably guess that one. So the LED is in here. There you go. It is basically connected in the current sync mode, which is means to say that the LED will going to light up when the cathode is placed into the GND. The cathode is less positive than the anode. The anode is connected to plus 5 volts, and if we're going to the OSC482, we can see that the signal with respect to the baseline, this is A, this is the channel A, and the signal initially is at about 4.806 volts. So there you go. This is 4.806 volts, which is almost the same as plus 5 volt based on the schematic diagram, which is in here. That's pretty easy to understand. And also for the RX, you can see that this is the baseline for the channel B, and it goes up. This is the initial voltage, and it is read as channel B is a 4.9 volt. That is a DC. You can see my setup in here. This is DC for the channel A, and also DC for the channel B. All right, that's pretty easy to understand. Let me see if my eyes can have with a white color background, which is I can remove my eyeglass right now, or I can put it. Okay, let's work first in the dark background, like the dark city in the Batman the movie, and enable the cursor in here, and there you go. You already enabled cursor. So what I'm interested to do is that I'm going to measure when the TX LED is keep blinking like that. So that is easy with the cursor by putting the cursor at the start of the blinking. That's my best position, and I'm going to choose the B, and there you go. So I put the cursor A at the start of the blinking, and the cursor B at the end of the blinking, and the time for the whole blinking process is about 38.642 milliseconds, this one in here. And to continue that, I'm interested to understand the time for the RX LED to respond, so I can make use of the cursor C. And the cursor C, I just have to put it right here. And how I'm going to read that, I'm going to go to cursor E and find the B to C. The B to C in here, it will take about 1.118 millisecond. That's Oh my god, that's 1.118 millisecond. I cannot even imagine that, how fast it is then. And finally, I would like to understand what is the time for the RX LED to response blinking, which is quite faster. That's my best position. And then I'm going to take a look at the C to D in here. So that is the C to D, and it will take you about 3.265 millisecond. That's how easy it is to understand about the blinking of the TX LED and also for the RX LED. Now, with the OSC482 oscilloscope, I can able to explain what is really happening in the TX blinking. You can see it's a series of on and off, very fast, and how the TX LED take time to blink, as well as the interval between the TX and the RX LED. And also I can see how the RX LED characteristic in its waveform. That's pretty easy demonstration on how I'm going to understand in a deep dive on simply on the LED. All right, let's go back to the waveform. And the other thing that I can do right now is I'm going to save that. So click this one, and it will save you like TX, RX, a waveform with the cursor. So you will know that this is basically a file with a cursor. And the other thing you can do is save that one, but the background will be white. Like I can remove my eyeglass in here, and to be more handsome like that, just like a rock star, and put that the background into white, and then click again the save. Easy for me to read right now. I think this is a good features really. And then save TX RX waveform with white background. There you go. It's easy as 1 2 3, and click the save, and you get it. Let's review that one. Now I can say that first is the TX RX waveform with the cursor, and there you go. It's easy as 1 2 3. It was save. And the second one is the TXRX capture with white background. Where is it? There you go. That is the white background, and it is easy as 1 2 3.